All right, hello and welcome. In this video, we're going to be looking at factoring the sum and difference of cubes. So when you look at this first example here, it just says x cubed minus 64. So this is actually pretty similar to things that we had worked in the previous section. The biggest difference here is that this exponent is a 3, not a 2, like we had done previously. So when I'm setting up my factoring, I'm definitely going to start it off in a similar fashion by taking the x cubed and putting it inside of a box. However, unlike last time, since this is actually has a higher exponent, I need to change up a little bit how I'm figuring out what happens with that last number. So what I'm going to do is look at that 64 and see if it has a cubed root. So the third root of negative 64, and if you don't know your cube roots, you can definitely do this on a calculator. But the third root of negative 64 is negative 4. So if I'm trying to figure out how to work with this x cubed, the number that I'm going to try to factor out is that negative 4. So what I'm going to do is take an x, put it on the side, take the negative 4 that I got from the 64, put it on that second row, and then from here we're just going to do division like we normally would. So I know I need an x squared on top to make x cubed. I know that the negative 4 and the x squared would multiply to a negative 4x squared on the bottom row. And then when I go back to my original expression, I notice that there's nothing else but the x cubed and the 64. So that basically means that anything else that I get, whether it's an x squared or an x, is supposed to cancel out to 0. So instead of having to just rack my brain over what's missing here, I'm just going to put a 4x squared here because negative 4 and positive 4 would cancel out when I add them. So in terms of my factoring, I need a 4x on top to go with the x to make 4x squared. I notice that negative 4 and positive 4 will multiply to a negative 16x. Once again, I have no x's in the top in my original expression, so I need a positive 16x to cancel the bottom row. If I see an x on the outside and a 16x on the inside, that tells me I'm missing the 16 that goes on top. And then if I set this up right, negative 4 times positive 16 should give me negative 64, which it does. So my factors are whatever's on the side and whatever's on the top. So I should see x minus 4 with x squared plus 4x plus 16. All right, so in our second example, we'll notice we're starting off with the same idea, only this time there's an extra coefficient in front of x cubed. But this isn't really going to change how we think of the problem. So the only extra step is that I probably want to check for the cube root of 8 as well as the cube root of 27. So if I cube root the 8, I get a 2. If I take the third root of 27, that gives me 3. So when I'm setting up my factoring, I'll copy down the 8x cubed. And then the numbers I'm going to try to factor out are a 2x on the top row and a 3 on the bottom row. And then we'll once again go ahead and do the division to figure out what goes on top. So 8 divided by 2 tells me I need a 4 with the x squared on top. 3 times 4 tells me I need a 12x squared on the bottom. I need to cancel the x squared with a negative 12x squared. Negative 12 divided by 2 gives me negative 6, and I'll bring the x up to the top. 3 times negative 6 is negative 18x. Which tells me I need a positive 18x to cancel it out. 18 divided by 2 is 9. And then if I double check, 3 times 9 does give me 27, which matches what I had in my original expression. So once again, my factors are whatever's on the side times whatever's on the top. So I should see a 2x plus 3 and a 4x squared minus 6x plus 9. So for our final example, what I'm going to do is look for a greatest common factor, or GCF, first. And my clue that I need to do this is that I see a matching x in both terms. So I'm going to go ahead and factor the x to the front. I also notice that 250 and 128 can both be divided by 2. So to make this factoring easier, I'm going to look for that GCF first to make my numbers a little bit smaller. So I've copied down my original problem inside the box, and now I'll do the division to get the second factor. So 250 divided by 2 gives me 125. If I need x to the fourth inside the box, and I've already got an x on the side, I need 3 more x's on top. 128 divided by 2 is 64. And then I've already got my x on the side, so I don't need another one on the top. So I've already discovered one factor from the original expression. However, when I look at what's left on the top, I notice something that matches the pattern of what we had seen before. So I'm going to follow the same steps as the previous examples, where I will start by looking for a cube root of 125, which is 5, and a cube root of 64, which is 4. And from here, I'm going to factor that top expression the same way I'd done the previous examples. So I'll start with my 125 x cubed. I'll factor a 5x on the top row and a 4 on the bottom row. And then I'll do the division to see what should go on the top of my box. So 125 divided by 5 is 25. X cubed divided by x gives me an x squared. 4 times 25 is 100 with the x squared. I need to cancel, so I need a minus 100 x squared since I didn't see any x squareds in my original expression. Negative 100 divided by 5 gives me minus 20 with an x. 4 times negative 20 is negative 80 with an x. I need a plus 80x to cancel it out since I don't have any x's by themselves in what I'm factoring. 80 divided by 5 is 16, and 4 times 16 is 64, which matches the final value in my original expression. So I've discovered two more factors for my original problem. I have the 2x as my GCF, which I already found. Plus, I've also got my 5x plus 4 and my 25x squared minus 20x plus 16 that I just pulled from my second box. So to completely factor the expression I was given, I need to copy down all three pieces. So my final answer, I have 2x, 5x plus 4, and then 25x squared minus 20x plus 16. That's all I have for this one. I will see you guys next time.